Hey guys, my name is Ginger and I'm here to talk to you about bioelectricity. What if I told you that the electricity flowing from the battery to the light in this circuit is really not much different than the electric signals traveling through your body right now? Elements in our body, like sodium, potassium, magnesium, and calcium, all carry a specific charge. These are called ions, and pretty much all of the cells in our body can use these ions to generate electricity. Most resting cells in our body are negatively charged, meaning the ions inside of the cell membrane are mostly negative. They are usually surrounded by positively charged ions. On the cell membrane, there are ion channels that allow ions to travel in and out of the cell. Cells create a current by allowing ions to move across the membrane, which creates an electric potential. Once these positively charged ions from the surrounding environment travel into the cell, it becomes positively charged, which become electric pulses. This is known as action potential. Our bodies use patterns of these action potentials to allow us to move, think, feel, and heal. These electric pulses are also how our cells communicate. Bioelectric signals act like a master regulator. They tell cells, you're going to be part of an eye, you're going to be part of a finger, or you're going to be part of a brain, etc. Forming neurons can actually read these electrical signals from the surrounding tissue. If the cells in the surrounding area are more negatively charged, the implanting nerve might, for example, form an optic nerve. If the cells in the area are less negatively charged, this might signal to the nerve that it should overgrow. Basically, cells read the electric signals of the surroundings and make a decision on how they should grow. Let's look at an example of how this works. Let's say we have a worm and we amputate the two ends of it. If we have normal regrowth with normal cells, we would see a head regrow on one end and a tail regrow on the other. If we were to have hyperpolarized cells, meaning they're more negatively charged, we might see tails grow on both ends. If we have depolarized cells, meaning more positively charged, we might see a head regrow on both ends. That all being said, what kind of applications does this have? We could use this to fix defects in the womb by manipulating bioelectric signaling and possibly repair defects in the womb as the embryo forms. This has actually already been done in labs with animal embryos. Another application of this might be fighting cancer. We could use bioelectric signaling to normalize certain tumors by exposing them to a drug that changes their electric potential. This could be used selectively to target tissues like a tumor while leaving the surrounding tissues unharmed. We could also use this in regenerative medicine to convince tissues and organs to regrow or even replace entire organs or structures. By understanding bioelectricity and how it controls the body's functions, it opens up so many new doors for medicine and healing.